Welcome to this session on Execution to Control. This is submodule 1 of 4. In this module, we'll explore how lessons from drilling execution are fed into control and review processes. We'll focus on the documents, data, and procedures that shape performance evaluation, and we'll see how these inputs drive continuous operational improvement. In this submodule, we have 5 clear objectives. First, we want to understand the key inputs from drilling execution that feed into control and review. Second, we'll look at the control and review process itself and how it is applied to drilling performance. Third, we'll identify the typical outputs from this process, including how risks are updated and how procedural improvements are generated. Fourth, we'll learn to evaluate the key input documents, such as daily reports, run and section summaries, and end-of-well reports. Finally, we'll look at how to apply lessons from execution in order to improve future drilling operations. By the end of this session, you'll see how execution is transformed into actionable knowledge that strengthens drilling performance. Let's begin by considering how we learn from execution. When we speak about learning from execution, we mean systematically capturing what happened during operations and using that knowledge to inform the control phase. Drilling is complex, and no plan ever survives unchanged once operations begin. By studying execution, we close the loop between planning, doing, and reviewing. This means every run, every section, and every operational adjustment contributes to a body of knowledge that can improve future wells. The control and review process begins with a set of critical inputs. These are the documents and data streams generated during drilling execution, and together they provide the raw material for evaluation. We start with the drilling program, including the forecasts. This serves as the baseline against which actual performance is compared. Next are the daily reports, which provide continuous updates on progress, cost, and key operational details. Run summaries then give us focused reviews of individual activities such as bit runs or directional drilling performance. Section summaries pull that information together, showing performance and issues across larger hole intervals. Management of change documentation is another vital input. It captures deviations from the plan, explaining when, why, and how changes occurred. End-of-well reports, or EOWRs, provide a higher-level summary that often combines lessons learned and key performance outcomes. Finally, digital data and logs provide the hard measurements, formation evaluation, wellbore conditions, and tool performance that underpin objective analysis. Each of these inputs adds a different dimension, and none can be ignored. When combined, they create the complete picture needed for thorough review. Now that we know the inputs, let's examine how control and review are actually carried out. The control and review process can be broken into 2 parts, control and review. Together, they provide the structure to assess and improve drilling performance. Control focuses on auditing. Here, we examine the quality of data, the accuracy of operations, and the effectiveness of procedures. We check compliance with standards and verify performance against expectations. The audit also looks at efficiency. Did we achieve the desired outcome with minimal waste of time and cost? Reliability is considered too, with a focus on how consistently systems and equipment performed. Review, by contrast, is more investigative. This phase seeks to understand performance, evaluate results, and update knowledge. We don't just look at numbers, we interpret what those numbers mean. Did operational choices improve drilling efficiency? Did they expose new risks? Review also focuses on identifying areas for improvement and capturing lessons that can be documented and shared. Across both stages, reports, data, and KPIs are the backbone. They give structure to the process and ensure that outcomes are not based on perception alone. The end goal is actionable improvement, turning execution data into better procedures, reduced risks, and stronger performance. With the process in mind, let's now see what the outputs of control and review actually look like. The outputs of control and review are where the value of this process is realized. First, there is the critique of execution, a clear-eyed assessment of what worked and what didn't. This critique ensures that lessons are specific, not just general observations. Next, the risk register is updated. As operations progress, risks evolve. Some risks may have been eliminated, while others emerge from unplanned events. Capturing these updates ensures that future projects begin with a sharper understanding of potential challenges. We also see updated procedural definitions and requests. This could mean refining existing procedures, adding new steps, or even questioning whether current practices remain fit for purpose. Areas for further investigation are identified, highlighting where data gaps or uncertainties remain. Beyond these formal outputs, there's improved understanding. Teams gain a clearer view of performance drivers, and that knowledge is documented so it can be transferred across wells and projects. Importantly, everything must be written down. Without documentation, the learning is easily lost. So, the outputs are not just administrative, they are the foundation for continuous improvement. With that established, let's now focus on the specific inputs most commonly used in drilling performance review. In this section, we place specific emphasis on the core inputs that feed into control and review. While there are many types of operational data, 6 stand out as most influential. Daily reports form the continuous record of operations. They track progress and highlight events as they occur. Run summaries provide detailed accounts of specific activities, giving insight into tool performance and operational choices. Section summaries then take a broader view, integrating the data from multiple runs to show performance across a complete whole interval. Management of change documentation is essential, as it records where and why plans were adjusted, linking cause and effect. End-of-well reports provide the structured wrap-up, summarizing performance, lessons, and conclusions at the completion of the well. Finally, digital data and logs add precision, providing objective measurements that underpin technical evaluation. Each of these inputs plays a different role, but together they ensure the control and review process is based on facts, not opinions. They are also the entry point for most investigations when events require deeper understanding. With these categories identified, let's now examine the role of daily operations reports in more detail. Daily Operations Reports, or DORs, are one of the most frequently referenced documents in drilling performance review. They are produced continuously during the drilling process and serve as the backbone of operational communication. DORs highlight areas of interest on a day-to-day basis. These could include deviations from plan, operational challenges, or significant achievements. They also provide cost tracking, allowing us to monitor expenditures as the well progresses. Key performance indicators are recorded here as well, helping us to benchmark performance and identify trends early. It is important to note that reviewing every single daily report in full detail is not always necessary. Instead, they are often summarized in the end-of-well report. However, when incidents or anomalies occur, daily reports become a critical investigative resource. They let us pinpoint the sequence of events, identify decision points, and understand how issues were managed in real time. Retention is also important. IADC reports, geological logs, and service company reports should all be kept alongside DORs, as they provide additional perspectives and technical detail for deeper review. So, while daily reports may seem routine, they are foundational to performance control. Next, we'll consider run and section summaries, which offer more focused insights. Run and section summaries provide a more concentrated view of execution, focusing on specific operations or intervals. They are typically generated by a range of service providers and specialists. Directional drillers, bit vendors, MWD engineers, mud loggers, mud engineers, cementers, and wireline crews all contribute their own reporting. Each provides insight into how their tools and services performed during a given run or section. The question often arises as to where these summaries are stored. Sometimes they are included in vendor-specific end-of-well reports. Other times, they are integrated into the final well-level EOWR prepared by the operator. The important point is that they must be captured, organized, and available for review. The value of these reports lies in their specificity. For example, a bit vendor's report may provide details on bit wear and performance that are critical for future bit selection. A mud engineer's section summary may explain fluid challenges that affected hole cleaning. These granular details may not be visible in higher level reports, but they are essential for identifying root causes and lessons learned. In short, run and section summaries bring depth to the review process. In the next slide, we'll look more closely at the information these summaries typically contain. In addition to identifying who prepares run and section summaries, it's important to understand the types of information these documents contain. First, they assess equipment performance and wellbore quality. This could include how tools behaved downhole or whether the wellbore remained in gauge. They also provide retrospective reporting, allowing teams to reflect on whether operations unfolded as expected. Cost tracking is another key function. Run summaries often provide a more accurate cost picture than daily reports because they can reconcile actual consumption of tools and services. KPIs are also tracked here, giving specific performance metrics such as rate of penetration, footage drilled per bit, or tool reliability. These summaries also distill the key points from daily reports into a more concise format. They allow engineers to step back and see patterns rather than isolated daily details. Importantly, they include after-action information, such as bit grading, tool analysis, and post-run inspection results. These details are critical for validating performance and guiding future tool selection. Taken together, run and section summaries are invaluable for connecting operational execution with long-term learning. They bring clarity to the performance story. Now let's move on to management of change documentation, which explains how and why the drilling plan evolves. Management of change documentation, or MOC, is one of the most critical inputs into the control process. It provides the official record of when and how deviations from the drilling plan occurred. The first function of MOC is to document when the process changed. This is usually tied to depth or time, so that later investigations can anchor the change to a specific operational point. Next, it records why the process changed. This means identifying what was observed, what issue was encountered in the plan, or where risk identification failed. The documentation then explains how the process changed. It outlines what contingency was applied and whether that contingency had been planned for in advance. In many cases, this is the only record of decision-making under pressure. However, there's one important limitation. MOC does not necessarily state whether the contingency actually worked. That evaluation happens later, during the review phase. For this reason, MOC is essential but must be considered alongside other data sources. Ultimately, MOC documentation provides transparency and accountability. It is the backbone of procedural learning, ensuring we understand not just outcomes, but also the decision paths taken to reach them. Next, let's move to end-of-well reports. End-of-well reports, or EOWRs, serve as the capstone document for drilling projects. They summarize the entire operation and provide a structured account of performance, lessons learned, and conclusions. EOWRs often include a review of key performance indicators, providing a quantified view of how the well was drilled compared to plan. They also highlight operational challenges, corrective actions taken, and recommendations for future wells. Lessons learned form a central part of these reports, as they ensure that both successes and failures are captured. It's important to recognize, however, that the quality and depth of EOWRs can vary significantly. Service companies, drilling supervisors, and drilling engineers may all produce their own versions, each with different levels of detail. Some focus on technical data, while others emphasize narrative descriptions. Additionally, post-control reports may attempt to consolidate these perspectives. Because of this variability, one must approach EOWRs critically. They should not be taken at face value, especially when based on uncorroborated or perceptual reporting. Cross-referencing with daily reports, run summaries, and MOC documentation is essential to build a reliable picture. So EOWRs are indispensable but must be used wisely. To illustrate this, the next slide shows how different reports combine into the final critique. Here we see a visual diagram showing how various reports and observations flow into the final end of well critique. At the top are the individual EOWRs generated by the drilling supervisor and service companies. To the side, we see supporting documents such as daily reports, run summaries, and MOC records. Geological observations and unreported field notes are also represented. In the middle, these inputs converge in the well engineering end of well report. This is typically the operator's formal consolidation of all perspectives. At the bottom, the control and evaluation process is shown, where all of this information is synthesized into the final critique. Key points to note. First, EOWRS are multi-source documents built from diverse contributions. Second, without a structured control and evaluation process, the final critique could be biased by incomplete or unverified information. The takeaway is clear. End-of-well reports are only as strong as the inputs behind them. That is why control and review must draw on all available sources, not just a single narrative. With this understanding, let's now revisit the original objectives and see how we've addressed them in this module. Let's close by reviewing the objectives we set at the beginning of this sub-module. First, we set out to understand the inputs from execution into control and review. We have examined these in detail. Daily reports, run and section summaries, MOC documentation, and end-of-well reports. Second, we aim to learn the control and review process. We discussed how auditing and investigative review turn raw data into actionable insight. Third, we identified the outputs, including risk register updates and procedural improvements. Fourth, we evaluated the key input documents and their role in shaping reliable conclusions. Finally, we looked at how lessons from execution are applied to improve future drilling operations. Each objective has been addressed, showing how execution is converted into continuous improvement. With objectives complete, we can now close the session. This concludes submodule 1 of 4 on execution to control. Thank you for your attention and engagement throughout this session. Please now proceed to the quiz, which will test your understanding of the key points we have covered. Once again, thank you, and I look forward to our next module together.